Okay. Yeah, today a short update on the usage of, well, especially map annotations and key value pairs in the context of our electron microscopy data in the OMERO server at CCAT in Cologne. And this is actually a continuation of a talk Niraj delivered here more or less exactly 2 years ago in this very room. Um, so what I did is I took just Niraj's slides to remind you of what the idea behind all this is. And it is to use OMERO MDE, the metadata editor tool yeah, invented and created by Susanne Kunis, we just heard, to provide our users, or especially my colleagues in the imaging facility, a tool to systematically annotate the electron microscopy images with standardized metadata. I think Joost yesterday already showed a little bit how OMERO MDE is looking like. Just to shortly recap this. So this is, if you're familiar with OMERO, probably more or less what you know. So as soon as you start the OMERO importer, you're by default here in the Select Data to Import tab, and then you can switch to the Specify Metadata tab and come to the MDE tool. And then you have some table-like interface where you have predefined keys and can populate values. And what we make use of is here's this setup dropdown where you can yeah, predefine these kind of templates and then switch to a custom one if you have. This is exactly what Niraj set up for us. What we set up, so this metadata scheme we used, is in principle based on some kind of early metadata standard which we developed here in this RDM4mic meeting. So you see the date is 2020. And this was some kind of list of fields which we back then considered like necessary as a minimum for, I guess we discussed it mostly in the context of light microscopy, but let's say in the context of microscopy. So what I'm showing this because you might be slightly irritated now that what we are using is not so much resembling the now very popular and recommended RAMBI standard. But yeah, this is simply due to the fact that we started working on this before RAMBI was even published. Exactly, and then here you see a view of the MDE window when we switch the setup to EM, we just called it. So here we switch to EM, and then you see this template changes. And what we also offer our users is here some default values. As you can see, many are or can be pre-populated with not applicable, especially those fields which are more or less specific to light microscopy and therefore do not so much apply to electron microscopy usually. And then what you can see is we have quite some fields here, and almost half of them show here these drop-down menus, which you can then use to fill in some of the predefined values. And yeah, how we came to these predefined values is that we in the institute had quite some discussions, quite lengthy discussions on which values are really required and yeah, which should be in. And of course, we also looked in our old records and checked, for example, which organisms were ever used in our institute to get a feeling on what values might make sense here. Then I think this was also already discussed yesterday, but just to show it in the interface a bit. If you click here on this menu button, a little menu opens, and there you have this option to load and save metadata templates. That means if you populate this list with values here, you can save this as a template. And if you are doing the same experiment over and over again, you don't have to fill in all the 26 fields, but you could simply load your template and maybe just vary the 1 or 2 fields which changed, if at all. Yeah, and this is then how it looks like if you look into the key value pair section in OMERO Web or also in OMERO Insight after you imported some images. What is important to realize? Only keys are created which were populated in the MDE editor before. So if you leave a field empty, that key won't be added. Yeah, then Neeraj also discussed some challenges we faced back then. One of which was that also MDE offers the possibility to include references to ontologies and then auto-populate the values with the ontologies. We made the experience that it then takes up to several minutes to just start the software because it's still pulling the ontologies. And even if that would be handled better, then there would still be the problem how to filter the values from the ontologies because there are thousands and thousands of organisms, let's say, and usually people use a much smaller set of these. So yeah, the obvious solution was just to, in the XML, use hard-coded, so to say, values for the specific terms. And yeah, this is then what Neeraj did. Finally in our template, we have these 26 fields here. And 10 of these have these drop-down menus. And this way can be filled in with predefined values from our control terms. What is also helpful in understanding what I'm going to show you on the next few slides is to realize that we have this template in principle duplicate. So once it's called default and once it's called manual. And the fields are exactly identical. However, in the manual section, there are no drop-down menus. And the reasoning behind that was that if in our, for example, control terms for the organism which we are offering, a specific organism is missing, then people don't have to wait until Neeraj or I or someone else manages to adjust the XML file, but can simply enter free text organism. In an ideal world, we would immediately notice that, correct it, and update our template. So yeah, I mentioned we have these 10 fields which have pre-populated values. These are organism, where, as you can see, we have, or had at least in the beginning, 10 possible values for selection. Imaging method, where we had just 3 possible values for selection. Cell line, 11. Orientation of sectioning, exactly 2. And in principle also here for serial section and clem, that's a yes-no question, whether it's a clem experiment or a serial sectioning experiment. Also for sample condition, we only offered 2 conditions, whether it's a cell pellet or cells grown on ACLA, or tissue on ACLA, I guess. Then some options for which heavy metals were used to contrast the samples, the standard protocols my colleagues are using to prepare the samples, and then quite a lot values representing the groups at our institute, so the work groups. Yeah. And at least for the fields I mentioned first, the organism, imaging method, cell line, and orientation of sectioning, all the values we used, we also upfront matched with terms from, in our view, suitable ontologies. So we in principle have a lookup table somewhere stating, okay, this control term corresponds to a certain ontology term. Okay, so what I want to show you today is a little bit of statistics I extracted from our OMERO server showing how this approach was accepted by our colleagues. So my first naive approach was to do it with this HQL query language on the OMERO server, which immediately gave me how many annotations we have and so on. But yeah, we failed to get a bit more complex queries run. And so I resorted to the Python API and easy OMERO to extract in principle now lists of how many map annotations, how many key value pairs, who created them, when were they created, to which data set are they assigned, and so on. So how many images were annotated, and this in principle can be answered by the questions, how many map annotations with the namespace MDE were created, since this is the only template in use in our group. And there's exactly usually one per image. And after creating them, so this maybe I didn't mention, if you create these map annotations with MDE, they are, from the user perspective at least, read-only. So they are created, they are displayed in OMERO Web and Insight, but they cannot be edited. So simply by counting how many, I can in principle get a quite reasonable estimate on how many images were annotated. And the answer is roughly 65,000. And here this pie chart shows how many of these annotations were contributed by which user. And you can see we have one power user using this and some perspective power users, let's say. And we can also break this down to key value pairs. So each map annotation can contain multiple key value pairs, obviously. And these were 740,000 roughly, which means per map annotations in average, we had a bit more than 11 key value pairs. So now we can use the temporal development of this. The upper line is the cumulative number of map annotations of all users, and all the other lines are then the respective single users. And what we already saw in the pie chart is we have one power user. But what we can recognize here is we also had some other very promising users which at some point stopped contributing. So there are good reasons for that, I can tell you. But we also have some users which either don't produce so many images, which is probably not the case, or which probably should be talked with again and be further motivated to adopt the metadata editor. So then I took a look at which keys in our template were most popular. The top bar is the overall number of annotations or map annotations done with MDE, so more than this would be not possible. And then you can see that there are some like imaging method, contrasting preparation method from the predefined category, which are very popular. And then some of the free text fields are coming like the user, which is almost always present as a value, and organizational stuff like project number, block number, and so on. And only later stuff like organism part or organism come, which is not so great, I would say. So I mean, of course, we have some samples which cannot be assigned to an organism, but I would say less than 10% probably. Same I did for the keys, for the values. Here, this asterisk means I skipped group and usernames because, as you can see here, organism part has just a couple, about 100. Organism part, here, a couple of hundreds. That's bullshit. No, what I wanted to say, so we have single groups which have like, for example, 10,000 images done in that time, and also users with a couple of, and then in this chart you would have seen now group names and usernames from our institute, which probably wouldn't be very interesting. What you can see is that, I mean, if you remember, the key contrasting was also quite much on the top in the key top list. And what you can see here is that my colleagues obviously almost always use a combination of lead and urane to contrast the samples, for example. And not very surprisingly, most of the time they're using our only electron microscope for doing transmission electron microscopy. Also the alternatives there would be tomography, which the device can also be used for, and something else I just don't remember. And the preparation protocol standard is rightfully named so it seems to be the standard protocol. And then you can see mouse is the most popular organism, then followed by Homo sapiens. Keep in mind that organism wasn't specified for quite some of the images. So then one thing I realized is we paid quite some or spent quite some effort in standardizing the values for the organism part field, but for some reason we didn't include it as predefined values in our template. So it was a free text field. And here you see what happens when people get a free text field. So first of all, prominently you can see some people prefer to write liver with the uppercase letter in the beginning, some with the lowercase letter. Then we have here this letzte Zelle im Schwanz. And here letzte Zelle Schwanzflosse, which I suppose is the same, but which will be supposedly hard to match with an ontology term. I'm not sure. And then what you also see is here lots of entries are brain related, and then have some cryptic suffixes. It's probably a strong indication that we should change that and also offer control terms for this organism part field. Okay, and then I had a look, and I told you we have this default section and the manual section. And then I had to look, okay, for which kind of values people switch to the manual section to check, what needs to be done to or what is missing in our controlled terms. Reason number one is new work groups came to the institute. We didn't update the template, and then the work group imaged a lot and was over and over again created as a value in the manual section. Then I picked up two organisms which weren't in our list before, so these probably also should be added now. And then the other thing is obviously one of our annotators had a different interpretation of what the sample condition and type means than we had. So this is pre-populated with this ACLA, so cell or tissue on ACLA file, or cell palette thing, so in which, yeah, what type of sample it is. And someone in principle puts this as an experimental variable and put in gene names there. And then also in the cell line field was a lot going on, but in my understanding also due to misunderstanding of what a cell line means. Yeah, okay, so much about the statistics. What I then also tried is to export an example data set with OMERO RDF. Yeah, reasoning behind this that in principle we have these ontology terms, or we know the combination or the assignment of our control terms to ontology terms, and it should be, as also Susanne mentioned in the previous presentation, possible to get the data or to have this semantic data extracted again or created again. But of course, if you just export it, you just get it like this. So it's an RDF file or RDF output in the terminal. So the idea would be, oh sorry, the title is covered, to have a plugin similar to this OMERO RDF Wikidata, which then matches these our control terms again with the ontology terms, and in the best case produces some useful triples, which then can be used for, I don't know, all kind of semantic reasoning. So this is just a mock-up, but if we're having the hackathon tomorrow, would be one of my ideas to work on. Yeah, okay, that's more or less it. So what are we going, or how are we going to continue this? Updating the control terms according to what we found is missing. Obviously, there are some users which could use some additional motivation to use the tools, and also some education or internal discussions to verify which values belong into which field and which not, and whether there are additional fields needed maybe. Then obviously it would be good to have something like a continuous monitoring of this, so that Neeraj and I more quickly realize if something is missing or if someone is lazy. Yeah, and then currently there are some initiatives going on in our institute to harmonize metadata institution-wide. I guess this will also affect our metadata template, so probably we want or have to update the fields and control terms we are offering in agreement with the institute guidelines. And then, of course, we also have to think about, or we should think about, how to harmonize it with the data we already have. And I mean, yeah, obviously what we are doing there is still falling a bit short of the RMB standard. Also, a lot of the information missing, I would say, is already collected either in the electronic lab notebook or as part of the technical information in the actual image files. So it should be it should be possible to consolidate this data and link it so that the users don't have to, if they want to submit data to a public archive, collect it manually. And of course, also one interesting thing would be to look at all the free text fields we have, whether these can, in some not completely manual fashion, be matched to controlled terms or ontologies as well. Yeah, that's it. Thanks. Yo.
You showed these pie charts in the very beginning. Maybe I missed that, but what is the actual number of users who use that tool? Is it only 5 out of all of infinity?
Well, it's actually no, it's 8.
I mean, how many users?
Yeah. Okay. I didn't say this clearly. So no normal facility users are using this. This is because in our facility it's organized this way that electron microscopy is done as a service usually. So only my colleagues in the imaging facility are doing this on behalf of our users, and they upload all the data to OMERO. That's actually the charming thing about using electron microscopy to try those stuff, because it's my immediate colleagues doing this on behalf of our users. So it's 100+ users, I would say, affected by this, but done effectively by 5 annotators. I deleted 3 annotators which didn't contribute a lot. Yeah.
A bit more question into the motivation side then. So is this something the facility staff just does because this is how it's supposed to be done? Then we just do it, zack, there it is. Now you have annotations. And the users just say, oh, cool, annotations, yeah, whatever it is, don't really care, but it's there, yay.
Mm-hmm.
Is it like that, or is it really used for searching stuff?
So in principle, all of that. I mean, one major motivation behind this was, or let's say, according to our original plan, the workflow was planned like this. Our colleagues upload and annotate and upload this, and then share it via OMERO with our users. And in our reasoning, that would then have the big advantage that our users get high quality annotated data and get annotated data in OMERO at all. So that in the second step, the users can also realize how beneficial it is to have this metadata in OMERO, so that the search in OMERO for them also works better. So I know my colleagues in the imaging facility now make use of this when they are searching images in OMERO, and kind of are realizing now that it really makes sense to add this metadata. Unfortunately, our users don't. So actually, all this analysis I did just run on our OMERO group, but just for fun, I checked on how many of these NDE annotations are over all groups on our OMERO server, and it's neglectable what is there besides the data in our group. So almost no images were shared with the users via OMERO. So unfortunately, it seems to be the case that there are other workarounds to provide the users access to this data.
Oh, come again. Almost no images were shared by OMERO?
Yeah. So this is, in principle, we have this just for our own reference in OMERO now. So according to our plan, data should either be moved to the users group, or if we want to keep it, be duplicated where this OMERO duplicates, doing this hard copy stuff, and then moved to the users group, including all the metadata.
Yeah.
But this obviously does not happen
So they
to a
just
big extent, at least
somehow
yet.
get the raw data from them and
Yeah, I just don't want to think. Probably most of the data is transferred via Münster, I guess. Yeah, so yeah. Yeah, another topic to again discuss with colleagues in Cologne.
are you giving but at least you have those power users. I think that's already like something to show for. Are you like dragging them along if you give like new OMERO workshops for new groups where they're like, okay, here's our OMERO, please give us an introduction, or you give like, okay, here's our 1 hour standard intro to OMERO. And now you see this power user who will tell you how freaking great it
You
is.
do not have other users as a microscope, all TM.
But you have light microscope stuff as well. Don't you have light microscope?
Yeah, we do have light microscopes, but we didn't even try to motivate or let's say we tried and failed to motivate our light microscopy users to use the MDE templates. So in every OMERO introduction, yeah, they are using, so OMERO is quite well adopted, I would say. But I'm offering them all the time, come on guys, we create custom templates for you. I think I also created 1 or 2, but they are not used, obviously.
Do they give you feedback why they're not using it, or is it just a general?
So I don't have any formalized feedback, but I think it's a general unwillingness to spend time on stuff which is not giving immediate return.
I have a question about biology. That is the human cost to make a new experiment lower than dealing with OMERO? I don't know.
No.
So I mean, especially the electron microscopy experiments tend to be yeah, quite tedious. So the sample preparation takes at least 1 to 2 weeks, if not longer. So I would say usually the answer should be no. It's much better if you can retrieve your results.
I think the general problem is that people feel they can retrieve the results even though they don't have metadata.
Yeah.
Right? They will remember everything, at least that's what they think.
I think the new PhD student does.
For the first 3 months, yes.
I didn't annotate any metadata in my PhD.
Yeah, but how
I never-
sure are you that the thing that you annotated?
I mean, I
before here is
annotated
true or
maybe
you
in
didn't
another-
check it?
Yeah, maybe I annotated in another way, like in my not electronic lab books and in the titles of my files. Yes, I did. That's why I can remember. But I think putting on the PhD students something else, they have to do so many things for free. They are paid very badly. They have very little time, and I mean, you're making it easy. That's great. But like that's something we need to be aware of. We can laugh about it, that they don't use it. And to me now, like 6 months working with Thomas, I also realized that it's stupid, that it would be great if they would do it, but I can understand why they don't. Like, why would they?
But I heard a different story, so I completely agree with you. It's another bird maybe, and this is why we try to do it as simple as possible for them. But I heard that if you get the students very early on in their career and teach them about data management and all these things, that they are very willing and that we should give them more credit because they're actually very open for these things. It's a new generation as well, right?
I think so. If you go to the graduate school and tell them, like, I had to do a good scientific practice course within the first, you need to go to the graduate school and say, like, within the first 6 months, where your also your first committee meeting should be, you have to do course on RDM also. I guess that would work, but
Yeah, we see that it comes.
yeah.
Yeah, so what we are going to try now for light microscopy is to switch from user-driven import via importer to in-place import, and it will only import with a minimum of metadata provided. And then we want also to restrict other ways to shuffle the data away. Yeah.